All right, and we're back after a few minutes break. So last we left off, we did the pointer lock thing. It worked. For some of you, it didn't work for other people. Try and use it in incognito mode. That might work a little better, so it doesn't cache. So again, I click in and I press escape, and it disables. And I can see that the pointer lock request is here and enabled and disabled. Okay, cool. So I've got my plane, but this plane is not really a plane, right? It's really a rectangular prism that I've used. I've positioned my camera so that it sees it like a plane. Let's take a look at that for a second, and I'll explain why I've done that, right? So I've got my, a couple things here. Hold on a second, I'll just pile out of here. I've got my spotlight. By the way, I've set my spotlight up for you guys. I already put that in the scene with some shadows and everything else just to display what we've got on the scene. Here's my ground geometry. And my ground geometry is just a box geometry that's 32 units on the x-axis, 1 unit on the y-axis. That's 1 unit tall. I could probably have made it half a unit if I wanted to, right? Or even less. And there's 32 units across the z-axis. So the x and z-axis define the size of your plane is 32 by 32. All right, I want to convert my ground. This is the first thing I want to do. I want to make my ground, and I called it burnt ground. This is what we did last time. I want to convert my ground into a fuzzy.js object, right? Because that's the first thing we need to do. To convert an object, and here's my ground object, into a fuzzy.js object, I need to do a couple things. So let's just go through the changes that you need to make for each of your objects, because this is important, right? Otherwise, you're going to try that in a 3JS object, and it's not going to work. You're not going to get any physics on it. And you're going to get mad, right? There's a couple things we need to do in order for us to start off, you know, listening and to start doing these you know, the simulation, if you will. So one of them is I've got my fuzzy.js scene, right? So I've instantiated a new scene object, and I do that up here so I can expose my scene, because remember, I'm in an IFI right here. My IFI is in a closure, so you can't see any of the variables. They don't escape. The only thing I'm allowing to escape is my scene, and that's why I've put it up here. Sorry, up here in my. I've defined it as a scene and instantiate my scene. But I need to do some more work in my scene, and it's going to happen pretty much after I've done all my pointer lock stuff, right? So I'm going to go into underneath my pointer lock stuff, which is right here. Just before I set up my renderer, I access my renderer and everything else, I got to set up a couple of additional things here, okay? Just to note what I need. So here, just underneath here, I'm going to instantiate. I've already instantiated my scene, but I need to create my physical world. Let's do a couple things. So we'll say scene changes for fuzzy.js, right? Fuzzy.js. And what are they? I want to do one thing. I want to name my scene. So I'm going to say scene.name. I want to call this my main scene, okay? Because we haven't done names for everything right now. By the way, I already did that with my ground plane. My ground plane, I gave it a name of ground, and my spotlight, I gave it a name of spotlight. You'll see why, because I can actually see them now, right? I want to add some fog. Why not? So we'll add some fog to the scene. So scene.fog, right? Again, this is right from the examples. New. You know, again, my 3 fog kind of effect is my fog. And in there, I want to make it so it's like a white fog. Changes with the near is far, and the far is 750. So let's say beyond 750 units, you're going to see that there is a bit of fog everywhere. There we go. That's one. I want to add an event listener to my scene. Okay, this is kind of neat. This is new for fuzzy.js. So I'm going to say scene.add event listener, right? And in my event listener, we're going to call it on updates. So whenever my scene updates, I want it to do something. What do I want my scene to do? Well, I'm going to create a fat arrow function here, right? And in my fat arrow function, I'm going to simulate. I'm going to call my scene.simulate. And this is what does kind of start off. It starts off my 3D simulation, if you will, my physics simulation. So it's the scene, right, as an example, and then .simulate. And inside there's 2 options. One of them is, if you notice, it says my time step. I'm going to put undefined for now. This is the standard. And then It says the second one is my maximum substeps. I'm going to leave that at 2. That seems to be a good rate. You can increase that. If you increase this, by the way, it gives you more substeps, which takes more processing power, right? So please don't up that too much. 1 or 2 is fine. Don't go anything greater than that. All right. Okay. So you've got those pieces in as an example. What we really need to do is we need to set up a clock, right? If we don't set up a clock, then we can't do things like testing for how long it takes between ticks. Right? So we want to be able to measure. Just like we've set up a clock before. Remember, we used delta time to kind of create almost like a physics-like update, similar to what we did in when we use things like Unity. We do a physics update, fixed update. This is the kind of stuff we have to do. But in order for us to set that up, we need to set up a clock, right? And I think I've already set up a clock as a type of clock. But if you haven't, notice up here, I've got a bunch of different imports that I use. One import that I'm going to put in here is a clock. So I'm going to say import clock, right, is equal to this 3JS clock kind of thing, right? Because if I don't do that, then I go 3.clock, right? I want to put that in there. So that's what I'm kind of making a an alias here. And then inside my variable, somewhere inside my variables, I want to declare my clock as a type of clock. So var clock is of type clock. That's what it is. So one imports it. It's just an alias. These are all my aliases. This one actually declares it. My clock, lowercase c, right? And then down inside, underneath, when we do our event listener, after we do our simulation, we want to add in a reference to the clock, right? And what I want to do here is I want to create a new timer, if you will. So I'm going to set up a 3JS clock here. These are all required sets, by the way. Let's say clock is equal to a new clock object. Right, so I kind of do that here in my setup. It's all before the renderer. All right, so my camera sets up, my renderer sets up. I've got all those. I've got my my ground and everything else, but I want to still do my simulation. And one thing I want to do is inside my my game loop, right? Inside my game loop is the next thing I want to do. I want to do 2 more simulations. One is inside at the bottom of my init function. I want to call a simulate. So under just where it says game loop right here, I also want to call scene.simulate down here. Scene.simulate. Again, some of this is workarounds, believe it or not, to make everything work properly, right? Otherwise, what ends up happening inside your scene, right, it won't simulate the physics properly. Wait till you guys catch up. All right. So we're going to use delta time to do things like move things around, right? We're going to need a clock to move things around. We're going to use things like the notions of velocity and force. We're going to apply forces. We're not going to use rotation anymore. We're not going to use position anymore, because position and rotation, by the way, if you try to set up a PhysiJS object with position and rotation, it will not work. Okay, it'll just like, you'll see it shift like really quickly like this. Because once you start simulations, right, with physics, it'll take the last location in memory, last position that the simulation took the object, and put it back there, right? That's what it does. So that's a little different than what we were used to in let's say, something like Unity, right? Unity allows us to use things like position and rotation. Not so here. We have to actually add a velocity to turn an object, add an angular velocity. We have to do things like add force to an object to move it, or impulse. There's different kinds of forces we can use in this particular physics engine. Okay, so we've set up all of our requirements, but now we want to make sure that we have to change our ground plane, as an example, into a physics object. Well, hey, our box geometry is cool. I'm good with that, but our ground material is not correct. All right, it's not correct. So notice how we have a ground material, which is this new Lambert material. Well, this would be good if we were doing 3JS, but not so if we're doing PhysiJS. We got to change our ground material so that it's a PhysiJS.material type. Let's go back up here. And why? You're going to ask me why, or you should ask me why. And the reason why is because our ground material also has not just a material like we're used to, but also two other properties. So think about it as a subclass of the material superclass for 3JS, right? It has two other properties. It has friction and restitution. What's friction? I know I kind of said it already. People should know. What's friction? Anyone not know what friction is? Resistance is force. It's the force that's resisting you on the ground. So it's a ground force that's resisting you when you're moving an object or pushing an object around the ground, okay? Or across another object, right? Restitution, what about that one? That one's kind of weird. What's restitution? I don't know what that one is. That's a new one for most people. Yeah. Bounce. That's what it means. How bouncy your object is relative to other objects. So those two things, so friction and bounce, that's really what it is, friction and restitution. So I need to change this ground material from Lambert material, which is what I had. I'm going to change this to a PhysiJS dot material. Now you might say, well, how come you didn't do your import statements up here because you did everything else? Well, I got to be careful because I don't want my material to clash with my 3JS material. So be careful. That's why sometimes I use PhysiJS down here. Again, I could have called this P material or physics material or something, but that's really what I'm creating here, physics material. Okay, and you can't separate the two in our simulation, which is kind of a limitation. Now notice I have an error here because I need to use another method to get this Lambert material into my physics material. I need to use this, PhysiJS dot create material, right? And then inside my create material method, I'm going to put this new material object inside of it, but it needs two other properties. One of them is, if I kind of look at it, one of them is friction, which is optional. For now, I'm going to set friction something low, like 0.4, and restitution, which should be like 0, so 0 bounce. We can make it low as well, like 0.1, something like that, if you want to make it more exact. They're optional values, but I want to show you what's the difference, right? So that's one thing. Number two, my ground is not a mesh. That's a 3JS mesh, right? I need to make it a different kind of object. My ground has to be a special mesh that's related to PhysiJS, right? So instead of a mesh, if I say PhysiJS, if I go dot, if I look at if it's a PhysiJS mesh, can I do that? Yes, I can. That's good. My ground is a PhysiJS mesh. Now it has physics can work on it, right? Now notice my PhysiJS mesh is the superclass for all PhysiJS meshes. That's what you want to think. Well, this is cool, but notice how I can't put just mesh in there. That's why I can't use the alias that I had before. I'm gonna have to put PhysiJS dot mesh in there, right? And I can still use my ground geometry and ground material. Now it's gonna work. Okay. So far, so good. There's one other factor here. We're missing, we've got ground material, and we got one more thing. If I press comma, look what else. I have another option. It says an optional mass number. What should my ground mass be? Think about this, carefully. Sorry? Who said 1? If it's 1, what's going to happen? It's going to fall. So it's got to be 0. So let's use our ground mesh. Actually, well, let's put it at 1 and see what happens, right? So leave it at 1, and now let's refresh the scene. Let's go back and see if this thing works, right? So if I refresh my scene, if everything goes well, then this ground mesh should fall down, right? Now it doesn't, right? Because something's not right. Let's see if we've got everything, all my elements in play, right? And again, I would check my console to make sure that this is all good. Notice that the ground didn't drop away, right? The ground did not drop away. And it should, right? It should. Here's the other problem that we have. We've defined this as a mesh. Yeah. That's a good thing. Where's the gravity? Where did I just kind of define my gravity? Where did I put my gravity? Anywhere in here? Did I define gravity somewhere? Well, this is the funny thing. My scene, by default, has a gravity, right? Has a gravity that's defaulted, right? So if I was to try and find out what my world gravity is, let's go back to my scene. We missed that piece. Here's my scene, my fog. you know, as an example, and if I say scene dot, and if I go set gravity, right? Now, if I set gravity, just be careful here. This is a number, right? If I set gravity to 1, right? This is going to be funny when you're going to see it. Watch what happens. You see set gravity to 1. If the physics simulation is working, this thing should jump like crazy, right? Now notice how there's something missing here. They work. The gravity worked on this scene, no problem. But the problem is it's not showing. So something else is missing, and some kind of my simulation is still not functional. I know that for a fact. My simulation, not functional. If it was functional, we would have our ground falling right now because our mass is 1, right? So that's kind of an important thing. Here's something else. You might see, and this is where if I was to do something like this, if I say, notice that gravity is a number, but if you look online, right, it says gravity is actually, it takes a vector, right, which is something that it should take, something like this. New vector 3 object should be something like this, new vector 3 object, and you can define your gravity in different steps. For example, 0 for the x value, minus 10 for the y value, and 0 for the z value. That's how it used to be, right? But not so anymore with this latest version of PhysiJS. It won't work. Because set gravity only takes a number. That's what it looks like. And if you check the actual the code, that's exactly what it is. Okay? Notice that if I put 0, it'll accept that too. Even if I put 0 or whatever I put in, if I go back to here, nothing. I know for a fact my simulation isn't working. Because otherwise, if it was, right, then this object would fall. Because it's got a weight of 1. Right? Let's go back. Let's check this out. Okay, cool. Here's my gravity. And by the way, this option, this gravity, the default is already there. That's why I didn't include it, right? So let me just default this for a second. Let's take it out of my scene just for a second. I've got my scene simulation. Normally you want to set the gravity or whatever it is. Okay. I've got my ground. I put in my ground color. I put my friction and my restitution. I set up my ground type, and that's really cool. One thing I missed, and which I recommend that you do instead of making a regular ground, and I know this is kind of crazy, but if I just define it as a mesh, PhysiJS doesn't know what it is, right? It's a type of mesh, and it's a plane, right? And you'd be forgiven to think that if you put something like plane mesh, right, which is the specific type of mesh that you're using, that it would be okay. You'd be okay with this plane mesh, right? You'd be forgiven to think that that's cool. What this does when the physics simulation actually finally works, right, for us, which is not working right now, when it finally works, right, and when this is finally fixed, this creates a plane that's endless. When you create a plane mesh for PhysiJS, it'll work forever. You'll never fall off the ground plane. It'll just create your ground plane, but then the box is a forever box, right? Which is kind of weird. So there's a couple of options here. And one of them that I like to use there's a couple of them. I found that convex mesh works nice, but it's expensive. So convex mesh. So if I was going to choose a ground plane, convex mesh. And the reason why this is better than what they suggest, which is a height mesh, huh? Well, it didn't work, but oh. Notice how it disappeared, right? Did it disappear for you? It should disappear for you, right? Let me show you this again. If I press refresh, oh, there it goes away. It goes to oblivion, right? So physics actually is working. Well, I remember I'm talking about things like, these are like, things I've worked on for I'm not joking around, guys, for about 2.5 weeks to get this simulation properly, right? So create this convex mesh is a reason for this. There's other options here as well. Here's another one. If I go height, if I type in height field mesh, would also work, right? Height field mesh. Height field mesh is a problem, right? Well, first of all, probably typed something wrong, but let's just save everything. And it looks like, for example, I got a bit of an error. It says type error, Z is undefined, somewhere in my physy.js. Take a look, my physy.js, my property, my cannot read property Z of undefined, right? Why? Because even though I've defined this as a height mesh, right, I haven't defined other kind of, defined other options, right? because the way I defined it as a mesh type. All right, let me go back and put this as a convex mesh. Okay. Now it should go no problem. Okay. Okay, so I don't want that to fall. That doesn't make any sense. So let's change this ground material mass to 0, right? Cool. Okay, I'm back. So now it stays there. So my ground is staying. Now let's add a block, and let's use the real physics simulation. I want a block to fall onto the mesh, right, and see what happens. So let's add a cube. So I'm going to add we'll call this our player cube, right? This is the cube that I'm going to move around for our simulation, our examples for now and for the next day. So I'm going to add a new, player geometry. Let's try this out, geometry, which is going to be a cube type geometry again. So cube geometry. I use the 3JS cube geometry for that, right? And then I'm going to define a player material, right? My player material, which is again a PhysiJS material, right? Because I'm going to define a material with friction and so on, right? I'm also going to define my player mesh, and I want to make this a PhysiJS mesh because we don't know what it is, right? PhysiJS.mesh. It's a standard mesh that I'm using. Now, I want to make it, it's going to be a cube material, a cube mesh that I'm going to use, right? But PhysiJS mesh will work just fine down here. So, okay, I've done my spotlight, I've done my ground, let's add my player. So add my player, right? So here's my player object, right? And I'll say my player geometry, right, is equal to a new box geometry. And let's make my box, I got to think about this carefully. My x coordinate is going to be, let's say 1, right? My y coordinate, how tall it's going to be, let's make it 4, right? And my z coordinate, let's make that 1 as well, right? So that's my box geometry for my player. Okay, so then my player material, this makes sense, right? My player material is a PhysiJS create material, and I'm going to use a new Lambert material where I'm going to pass in a color of green. So R, right, 0, G, FF, 0, right? Okay, cool. And now at the end, what I want to put in is my friction. Let's leave my friction low, like 0.4 and 0, right? So no bounce. I'm not bouncing it at all. I'm saying no bounce for my player, right? We'll play with this value next day. Now my player is equal to a new PhysiJS cube mesh. If I go cube mesh, notice how my code hinting comes up really slow, right? So player is equal to PhysiJS dot cube mesh. Is there a cube mesh or box mesh? There's a box mesh. Box mesh. And my box mesh needs my player geometry and my player material. And I also need to define if it's got mass, which I'm going to give it a mass of 1. All right. I'm going to say my player dot receive shadows. Right. My receive shadow, if I spell it properly, receive shadow is equal to true. And I'm also going to say my player cast shadows. I want to be able to cast shadows too, right? Cast shadow is also equal to true. And my player dot name is going to be equal to player. That's my player object. And I'm going to add my player to the scene, right? Console.log, tell me that. That's going to say added player to scene. Okay, if all goes well, console, Tom, console. If all goes well, when I save everything, I have a player, but it's going to appear right in the middle of my scene. So where should I put my player's position? That I can do for the first time. I got to put it up somewhere, right? So maybe I'll say player up here, player on line 145, player dot position dot set, and I'll put it something like, I don't know, 0 dot, so x is 0, but y is going to be like 30, and then z is going to be 0, right? So 0, 30, 0, so it's going to be way up in the middle of the screen, right? And now when I reset my thing, you should see an object that's in the middle of the screen this way. Let's check this out. I'll reduce it so you can see it, and let's refresh and see what it looks like. So this is what you see. Bam, right? So you should see that. Notice how the simulation played, whether I was playing or not. Does everyone have that? Let's make it a little fatter. My player is a little bit too thin. He's too anorexic, right? So make it so it's like 242. Let's see if I can make it like a 242 box. Right? So I kind of reset, and let's see what happens. Right? Bam. Right? There's my player in the middle of the scene. Right? My player is a box, and if you notice, he looks like a taller box right now. That's receiving shadows just on the top because of where my light's positioned in the scene. Right? Why didn't I make my player a capsule? And that's the next question I'm going to ask you, because I could make my player a capsule. It's hard to do, I'll tell you right now. And it falls over on a regular basis because it needs constraints. You can do everything you want, right? Yes. Yeah, there's many ways you can do it. You can actually combine the top. You can kind of smash the two spheres, top sphere and bottom sphere, and then a middle cylinder together, and then smash those together to make a capsule, and it becomes a capsule. And I'll show you guys how to do that. I recommend, it's going to be more difficult if you use a capsule. It looks nice, and it'll feel nice, but the difficulty is huge. Okay, cool. I've got my box. This is where it is. Let's put it a little closer to my scene. If I want to put it up here in front of me, what do I have to change from a position possession? Okay, so what should I make my Z? Minus? Okay, so say minus 15, let's say, and see what happens. So I'm going to put minus 15. I reset my scene, and then I can see my box a little bit more clearly. Hey, what happened? Hey, and look how it falls off. So it actually does the whole physics simulation for you. So let's do that as what it should be. You said minus 15. I like you. Well, let's try it again, right? And let's see it. Here it is, my box, and look how it falls this way now, right? Because it falls off the regular side as well. Let's make it so it's minus 10, or just 10, and go back so you can see the physics again. And there it is. Notice how it actually rocks a little bit when it falls. How come? There's no bounce, but it's doing this little rocking thing, right? We got to talk about that. And what about if it's really small? If it's not a box that's 242, but a box that's actually 222, like this. How come it does this? Take a look at the box now. It kind of bounced, even though I put bounce to 0, and actually squashed. You actually see a little bit of squash in the box too. Because PhysiJS isn't a perfect physics simulation, A. B, we're dropping it from a big place, and what's happening is the ground plane is pushing back on the box. So actually physically trying to smush the box, right? And what's happening is it's got a bit of, the box has a little bit of flexibility because we haven't defined that piece to it, right? So what's happening is it's bouncing back up. Not because there's bounce, but because the box is falling from 30 units high and smashing the ground, and the ground is pushing it back up. That's why it's doing what it's doing. Questions before we end for the day. This is the first piece of our simulation. All we're doing is making a box fall. Here's a try for you guys. Try and add a bunch of random boxes and random things on the screen, and let's see when your physics simulation stops or when it actually slows down a lot. Right now I'm still running at about 60 frames per second, right? Let's see what happens when you run it with more. I'll see you next day on Wednesday. We'll do more, and we'll add movement to the box.